All right, so this is quiz number 7. So first it says, knowing that sine of theta equals 3 over 7, we have to find all the trig ratios. So we'll start with the easy one. We know sine because it's literally printed there, 3 over 7. And then we also know the inverse of that one. So the inverse of that one is cosecant. So cosecant is 7 over 3, because again, this is the same thing. You're just going to flip sine. For the other ones, we have to do a little bit of work. So cosine, if we remember, SOHCAHTOA is opposite over hypotenuse. Wait, no, that's not right. That's sine. Cosine's adjacent over hypotenuse. So we'll make that an A over H. And then secant, remember, secant is flipped version of cosine. So this is going to be hypotenuse over adjacent. For tangent, tangent is opposite over adjacent. Cotangent is the inverse, so we flip that. We do adjacent over opposite. So the trick here is we know this is 3/7. So sine is opposite over hypotenuse, which is 3/7. Cosecant would be hypotenuse over opposite. But we know that the opposite is 3, and we know that the hypotenuse is 7. So what we could do is we can draw the triangle. And I'm going to draw the triangle like in the notes, where we have theta all the way up at the top here. So if theta is there, we know the long side. That's not a great triangle, but that's okay. The long side is the hypotenuse. If we look at sine, it says the hypotenuse is 7. So we're going to make that 7. Adjacent side is the one that's touching theta. So this is the adjacent side. And then the last side down here has to be the opposite side. But if we look at sine, opposite is supposed to be 3. So, okay, that seems pretty reasonable. To get the adjacent side, we just need to do the Pythagorean theorem, which we could do. So Pythagorean theorem is going to be a squared plus b squared equals c squared. And we got to remember c is always the hypotenuse. So in this case, we got to do 7 squared equals 3 squared plus b squared. Again, it doesn't really matter. You could do a squared plus 3 squared if you want. Those two you can flip-flop around. When we get down to it, though, 3 squared is going to be 9, not 9 equals. So 9 plus b squared equals 7 squared is 49. We could subtract 9 from both sides. So we get b squared equals 40. And now here we can square root both sides. So if we square root both sides, I need a little bit more space. So I'm going to come over here. So we get b equals, now again, I could do plus or minus the square root of 40, but we're doing the principal root, so we're just going to consider it to be regular square root of 40. Now, we got to be careful because square root of 40 can actually break down. So we don't want to report this as square root of 40. This is going to be the square root of 4 times the square root of 10. So b is actually 2 times the square root of 10. So we know that our adjacent side, we finally figured it out. It's 2 radical 10. So again, this is not one of the special triangles. So we don't just double it. We don't just multiply by square root of 3. We have to use the Pythagorean theorem. But the nice thing is, from here, it's pretty clean. So adjacent is 2 radical 10. Hypotenuse is 7. Hypotenuse is 7. Adjacent is 2 radical 10. But we got to be careful because, again, here we're not allowed to have these square roots at the end and the bottom. So we're going to have to multiply both by radical 10. So we get 7 radical 10 over 2 times square root of 10 squared is going to be 20. So that's what we get for our final answer. Here we don't need to reduce because 7 over 20 wouldn't reduce. Cotangent, I'm just going to do cotangent over here since I'm already on the bottom. But we have adjacent, which is going to be 2 radical 10. And then opposite is 3. So the nice thing is the square root's on the top. If the square root's on the top, we don't have to do anything. So that makes that one kind of nice. For tangent, we have to do 3 divided by 2 radical 10. Now again, just like with the secant, square root's on the bottom, so we have to multiply the top and the bottom by radical 10. So we're going to get 3 radical 10 over 20. And that's going to be our result. So those are going to be all 6 of our answers. So again, this is probably the hardest version of this question because we had to not only break down the square root, but then we had to use the square root and we had to multiply both the top and the bottom by any square roots that we saw on the bottom in order to get it to work out. Here I didn't break down square root of 10 any further because if I think about my perfect squares, I've got 4. You can't do 10 divided by 4 cleanly. I got 9. You can't do 10 divided by 9 cleanly. And then I'm past 10. So I'm out of perfect squares to try. So I wouldn't do anything else with this square root of 10. Even though it is 2 times 5, it's not a perfect square, and we only want to divide by perfect squares when we're breaking these down. All right, so that's number 1. Number 2, so this is a special triangle here. So it says 30, 60, 90 triangle with a hypotenuse of 8 when theta equals 30. So if we really want to draw out the triangle, we can draw the triangle out. We got 30 degrees here. The hypotenuse is 8. We need to find the ratios of sine and cosine. So again, here we're dealing with theta being 30. So this is the theta for this triangle. So we're doing thetas over here. So the short side, whenever we have the 30, 60, 90 triangle, is always the long side divided by 2. So 8 divided by 2 is 4. So the short side here is sine, because this would be the opposite. So we're going to do 4. Not 4. Yeah, 4. Let's see. Oh, we got to get the ratios. Never mind. We don't have to actually divide. Wow. That's really convenient. They just want the ratios. I did too much work. It's 1/2 of 8, so the idea is we have to get half. So sine is 1/2. If we do actually do it, we would get 4, so we could calculate it to be 4/8. For cosine, again, what we would do is we would then take this value, and we would do 4 times the square root of 3, because again, the longer side is always the short side times square root of 3. So there we go. So this is going to be square root of 3/2. Again, if we really wanted to calculate it, we would do adjacent over hypotenuse, and then 4 and 8, we could divide those both by 4 to get square root of 3/2. And that's it. So that's just knowing those ratios, and we're all set. So that's what we got for number 2. For number 3, if tangent is theta equals cotangent of 10 degrees, what is theta? So to get theta, what we can do is we can quickly use our cofunction identity, which says that 90 minus theta is equal to cotangent of theta. Now here, we kind of flipped everything around, so I need to actually reverse my cofunction identity. So tangent of theta equals cotangent of 90 minus theta. And now we could see, in order to get 10, I need 90 minus theta to be equal to 10. If I do minus 90 both sides, negative theta equals negative 80, divide by negative 1. So I get theta equals 80 degrees. So we're going to get 80 degrees. So that's using the cofunctions. Obviously, that's a little bit of extra work. We can visually see, well, I know I need to add up to 90, because in a triangle, the 2 angles have to add up to 90 other than the right angle. So 80 plus 10 would give me 90. I could also do it that way. So that's what we got for number 3. All right, for number 4, list the reciprocal identities for each of the trig functions. This is just knowing which ones go with which ones. So, I mean, I got the whole list of them all the way over here, so I could go back there and look at my choices. But sine is 1/cosecant of theta. If I just write CSC, it's wrong. CSC is not a thing. CSC is a function. So sine of theta is a function of something. So we have to reply with a function of something else. If I just write 1/CSC, it's wrong. It's not right, because you haven't gotten the identity. You just wrote down some letters. For cosine would be 1/secant of theta. And tangent would be 1/cotangent of theta. And if we know these ones, all the others are just the reverse. So 1/sine of theta for cosecant. Secant is 1/cosine of theta. And then cotangent is 1/tangent of theta. And that's what we got. So those are kind of nice. Don't expect them to be in that order. So again, don't just memorize the order of them. You will have to know which ones go with which ones. For 5, angle has a reference angle measuring 52 degrees, and its terminal side lies in quadrant 4. We got to get a positive and a negative value for the angle. So if we know that the reference angle is 52 degrees, we know that what we can do is come to quadrant 4. 1, 2, 3, 4, and just make an angle that we claim is 52 degrees. So that's our reference angle, that's 52 degrees. So if I want to get a positive angle, remember I need to go around this way. I got to go counterclockwise, starting at the x-axis. If I count, this is 90, 90, 90, and then this over here would be 52, 90 minus 52. So this would actually be 38, would be this piece right here, because again, these have to add up to 90. So I get 270, 308. So one possible choice is 308, not 3080, but 308 degrees. Now, if I wanted to, I didn't have to do that. I could have actually gone all the way around to where I needed to go. If I really wanted to, I could have kept going. I could have made another loop. So if I want to do a second one, I could. Again, if I would count it, it would be a whole circle. So that would be 308 plus 360 for 668. I don't know why I would pick that, but if I wanted to, I could do that one. So again, just to be aware, we're going to get every 360. If I want to get a negative angle, I'd have to go backwards, but that's kind of nice and easy. That's just negative 52. If I didn't want to calculate that, again, I could just take my 308 and do 360 minus 308. If I do that, I'll end up at 52, and that gives me my negative 52. If I want, I can go even further. I could do negative 52 plus negative 360. So 214. I could even say negative 412 if I want. All those would be acceptable answers. We just need one. So if you want to do those 308 and negative 52, that's what it would be. But just be aware you can keep adding or subtracting 360 to get angles that would work out. For 6, what's a possible measure of an angle that has a terminal side in quadrant 3? So again, we're going to look at our quadrants. 1, 2, 3, 4. So we know we're over here. And it makes it a 30-degree angle with the x-axis. So we have 30 degrees now this way. Again, this is kind of the same question for the positive angle. We would go this way. That's going to be 210 degrees because we'll get 180 plus 30 for 210. If I want, I could add 360 to get 570 degrees also. If I want, I could also just subtract. I could do 360 minus 210 to get 150. And then I would know that my negative angle, if I were to go around this way, would be negative 150. And again, if I want, I can add 360 to that to get the next negative angle for 510. So I could keep going if I really wanted to. I don't, so I'm not going to. So that's what we got. For number 7, what are possible measures for the angle shown? Select all that apply. So again, we're kind of doing the same thing. Since this is 60, we know that this has to be 30 because they have to add up to 90. So if I were to travel this way, I would have 90 plus 30 for 120 degrees. So I'm going to see if I got 120. I do have 120 right here. Now, if I add 360, I'm going to get 480 degrees. So I know everything between 120 and 480 are wrong. So that's how I know I can get rid of these safely. If I go the other way, if I do 360 minus 120, I'll end up at 240. So that's my negative angle is if I go this way. Again, I could also add 90 plus 60 to get to 240. So I know I've got negative 240. If I want to check if 540 works, I'd have to do 2 negative 240 and then another negative 360. I can just add them up, though, to get 600. So I know the next number I would be at would be negative 600. That's not negative 540, so that's how I would finish that up. So I'd only pick E and B. For 8, we have to convert to degrees. We just want to know the conversion factor is going to be 180 divided by pi. Here the pi's cancel out. And here we just want to find out what this would be in simplest terms. So if we do 180 divided by 4, that's 90 over 2, which is then 45. So this is 45 degrees. 7 pi over 6, same thing. We're just going to multiply by 180 over pi. These would cancel out to be 30, and 7 times 30 is 210 degrees. And that's it. If we want, we could get a little fancy. I mean, we could make the circle. We could slice it into 8 slices. And then remember, if there's no number up here with the pi, that's a 1. So we go 0, 1. And I mean, we can kind of eyeball that. We can kind of know, well, yeah, that's got to be 45 degrees because that's half of the first quadrant. Half of 90 would be 45. So we could do it that way too if we don't want to use the conversion factor. Would it work for this one too? I believe it will. But let's see what we can come up with. So 6 on the bottom means we have to do 12 slices. So the best way to do that, let's go ahead and make 6, and then we'll cut that in half. That's not looking very good. Let me start over. I don't like the way that one looks. All right, so let's make the circle. And let's cut it in sixths first. Let's not do the up and down line yet. All right, and then we got to cut each of these slices in half. So half, half, half. Nope, not half there. Oh no, all right. This one's not going so well. There we go. So half, 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 and then half, half. That still doesn't look very good, but let's see where we end up at. We're going to call it a day on that circle. 0, 1, 2, 3, 4, 5, 6, 7. And yeah, it's the one that's a little bit past. We know since we're cutting it into 12 pieces, we know each piece should be 30 degrees. So we could even count if we wanted to. 30, 60, 90, 120, 150, 180, 210. So even with a picture that's not very good, we could still get to 210 degrees. That's it. For number 9, it says give the exact values. So what we want to do is come up with our circles again. So I do need to draw the circles. First 2, I think I'll be okay. Did pretty good cutting it into 8 pieces last time. So hopefully we'll cut it into 8 pieces again this time. Remember, the number of pieces that we do is going to be the bottom. 4 times 2 is 8 slices. Then we count to the top. We got to count to 7. So 0, 1, 2, 3, 4, 5, 6, 7. So that tells me that I'm down here. All right, and then sine, we have to remember that sine is the y value. So the y value for this coordinate point is, well, it's just square root of 2 over 2, but it's below the x-axis, so it's negative. And there's no calculations on that one. We just are supposed to know that one from all of our common options. If we do cosine of theta is x. And so our x coordinate, again, we could draw that triangle if we really wanted to, is the same as the y. So it's square root of 2 over 2. This time it's positive because we're going to the right. And then the last one we have to do another circle. So we have tangent of negative 5 pi over 6. So if I do the circle for this one, here I know 6 times 2, times 2 is going to be 12 slices. So I got another chance to make a 12 slice one. All right. All right, that looks okay so far for 6. Cut it in half. Cut it in half. That's not too good. Cut it in half. Cut it in half. Cut it in half. Cut it in half. All right, other than that slice, I feel pretty good about that one. That actually looks like a pretty good one. All right, so we got 0. And since we're negative, we're going backwards. So 1, 2, 3, 4, 5. All right, so I know the one that I want is right here. All right, cool. I can write down the answer because I know this one, square root of 3 over 3. If we didn't know that one for tangent, you may want to do some extra work. You might want to remember that tangent of theta is sine of theta over cosine of theta. That way you don't have to memorize square root of 3 over 3. You only have to memorize the sines and the cosines. Those are really the only ones you have to memorize. So for this sine, we can see that this triangle, if we do the reference triangle, is a 30, 60, 90. The short side goes with sine because the short side goes with the y. So we've got negative a half. The long side goes with x. That's negative square root of 2 over 2. Sorry, negative square root of 3 over 2. I don't know why I wrote 2. Because again, 30, 60, 90. Yeah. All right. So the 2's cancel. The negative signs cancel. And so we're left with 1 over radical 3. Now again, square root's on the bottom. So to make the square root go on top, we're going to multiply by the square root of 3 over square root of 3. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is 3. And we do get to our answer. Again, it's a little bit of extra work, but if you don't want to memorize all the values, this is the best way to do it, that you can just memorize a couple of the critical ones. All right, for 10, what's sine of theta if cosine of theta equals 4/5 and theta is in quadrant 4? So we're going to put theta in quadrant 4. We've got 1, 2, 3, 4. So we know we're down here. So for cosine, we know cosine of theta is going to be adjacent over hypotenuse, which is the same as x over the hypotenuse. And this is 4 over 5. So in the x, I need to go 4. 1, 2, 3, 4. I can just draw in this and claim that my hypotenuse is 5. Since I know that's 4. And then I need to use the Pythagorean theorem to figure out what the last side is. Now for this one, I really don't need the Pythagorean theorem. We probably know it's going to be 3 already. But just in case, let's run through a squared plus b squared equals c squared. 4 squared plus b squared equals 5 squared. So 16 plus b squared equals 25. Minus 16 minus 16. B squared equals 9. Square root both sides. B equals plus or minus 3. And in this case, we can see that we're going down. So we're going to choose the minus 3 in this case. So to get sine, our value for sine is opposite over hypotenuse. So here the opposite is going to be negative 3. The hypotenuse is going to be 5. We could also call that y over h. In this case, theta is over here like it usually is for our reference angle. That's it. That's all we got for that one. All right, and last one we got, number 11, for theta is equal to 300 degrees, give the exact values. So in class, we tended to convert these. You don't have to convert it if you don't want to, but a lot of people, it made sense to draw the triangle or draw the circle out. For 300 degrees, if we do 300 times pi over 180, 0 and 0 cancel. We can divide both of those by 6, so we get 5 pi over 3. So this tells me that I want to split it into 6 pieces. So let's go 0, 1, 2, 3, 4, 5. So we're down here. So this is the one that we want to pick. All right. If we do our triangle, remember we always go to the x-axis. And this one I didn't really draw too well. But with this one, there should be a short side. This should be the short side. And this should be the long side. So again, we got to be a little bit careful with our drawing. Mine's not the best. Well, that is a little bit longer. Is that longer? Now I'm kind of curious. We got that. Paste it. That doesn't, that changes the size of it. That doesn't look too good. Okay. The way to fix it is to draw a better circle. So we'll draw a better circle. Oh boy. Use the actual circle tool. Let's cheat. So there's a circle. All right, so you know what? Let's even cheat some more. Let's go with a straight line. Where's my line at? We'll do another line. Thinking like there. Yeah, look at that. So now that looks good. See, all we got to do is make a professional circle. 0, 1, 2, 3, 4, 5. And now when we do our line up, it's very clear. We got a short side and a long side. See? Just make a better circle. Either way, so sine itself, remember sine is going to be, in this case, the y value. So the y value for sine, we're going to get y is the long side here. So this is going to be square root of 3 over 2. We got to be careful because it's going down. So we want negative square root of 3 over 2. For cosine, cosine is the short side. We're going to the right. So this is x. This is going to be 1/2. For tangent, tangent is the slope. So tangent is y over x. So that's negative radical 3 over 2 over 1 over 2. Here the 2's cancel, so we get negative square root 3. That makes sense. That looks steeper than 1. Square root 3 is bigger than 1. Cosecant of theta, we would just flip this. So negative 2 over radical 3. Again, we have to multiply both by radical 3. So we get 2 radical 3 over 3. That's a negative. For secant, we would just flip this one. So 2 over 1, which is 2. And for cotangent, we would also flip this one. Now we got our option. We can either flip it from the beginning or we can flip it from the end. I feel like it's going to be easier to flip from the end. Negative 1 over radical 3. And then we just multiply by radical 3 over radical 3 to get negative radical 3 over 3. And so that gives us all of our values. And that's it. That's all we got. Now you'll notice didn't use the TI at all. Didn't use any calculator. So I'm going to go back through for this one and actually show some things you can do with a calculator. But this is really a no calculator test. You really shouldn't be using the calculator at all. It's just going to slow you down. But if you want to use it, I'll show you a couple things you can do. So for this one, it says knowing that sine of theta is 3/7, we could find everything else. Again, not really much we could do. If we want, we could find the inverse sine of 3/7. Not that. Oops. Wrong button. So we would say, yeah, no, that is right. Inverse sine. Because we can do the inverse sine of both sides to figure out what theta is directly. But we're going to see the big problem with that. We've got 3/7 as a fraction, so so here is the problem, is that that is not a nice number at all. So we can't really do much with that. If you remember, again, your trig from geometry, I guess we could keep 4 decimals. I mean, don't be lazy. You got a calculator. Keep all the decimals. We'll store that answer as A. And then we would have to figure out, okay, well, that's what theta is. So what is cosine of theta? So what is cosine of A? And you'll see that you don't really get a nice answer there either. 0.90350799029. That's not what we want. We want 2 radical 10 over 7. If we do 2 radical 10 and then divide it by 7, we actually do get the right answer. So there is a way to check it. It's just very esoteric, I guess. It's not really worth your time. But you can do it if you are very paranoid. This is a way to double check them, is you could do the inverse trig function and then do each of the trig functions. If they come out nice, it works out. So if we do A, where's A? It's right there. So tangent of A, again, that didn't come out nice. Sine of A, I think also not going to look very nice either. Yeah, so unless you can recognize that and say, let me just change that to a fraction real quick, you're not really going to get anything if one of those square roots does appear in the answer. So the calculator doesn't help out too much for number 1. For number 2, Again, the calculator really doesn't help out too much. We could draw the picture out. We could get the 8, and we could just find all of the sides, same way that we found those sides. If you didn't know those ratios, you could actually solve them. So you could set them up. Sine of 30 equals x over 8, and do 8 times sine of 30 to figure out what this side is. We can put that in 8 times sine of 30 degrees. But again, it's not really worth our time to do that just to get back to 4. And again, we won't actually figure out what that is with the square root, so we'll be out of luck on the other part also. So square roots kind of block us from using the calculator. Number 3, I guess we could check our answer. So we could do tangent of 80. But again, that's not really super helpful. 1 over tangent of 10. Oh, these are all degrees too, so this isn't even going to be right. So I'm going to do this. Apps, degrees. We don't want tangent of 80. We want tangent of 80 degrees. So I mean, we could check that way, but again, seems like we're just slowing down. We're just wasting our time here. For number 4, can't do anything with the calculator. You just gotta know those ones. That's just memorization. For number 5, I guess if we want to use the calculator to add our 360 or subtract 360, that would be useful there. Same deal with number 6. Same deal with number 7. So there, I guess you could use the calculator to do some simple adding and subtracting. I did it all out by hand, but if you prefer the calculator, there's nothing wrong with that. Converting to degrees, again, not really much there. I forget if there is a convert to degrees feature. Pi over 4. If there is, it's probably in the angle menu. Degrees, meters, minutes, seconds. Maybe that'll work. No, not really. So you just got to kind of know that. So that's all we got for that one. Moving on. Give exact values with all those square roots. You know you're out of luck. Can't really do much with it. If we put in sine of 7 pi over 4, oh, I still at the end there. We can see, yeah, that doesn't really help us unless we know, which is possible. So this one, I'm not going to blame you if you have this fraction memorized. If you know square root of 2 over 2 is 0.707106872, if you can identify that more power to you on that one. Then you can use the calculator here. Because again, remember, the only fractions that we would normally get on that unit circle are the square root of 2 over 2. We would get square root of 3 over 2. So 0.866, and then a half. So a half is just 0.5. So if you do know those decimals, I guess you can use the calculator on these ones. You just have to know what you're going for. For tangent, obviously, it's going to be a little bit harder, but you'd have to just do tangent as sine of theta over cosine of theta, and then kind of manually do it from there. So 10, again, if you want to use the calculator to help you out with the Pythagorean theorem, that's fine. Other than that, you can't really do much with the calculator on this one. And then for 11, again, since we're given exact values, you can't really do much. You kind of got to do it by hand. This one is on the unit circle, so if you do want to double check some of these ones, because we got, again, square root of 3 over 2, so that's 0.866. You got 0.5. So as long as you know those ones, you could use the calculator to help out for that. So that's it with the TI. There's, again, not much you can do with the TI on this one. This one's kind of all you, which is good for our last one. So give us a nice little boost. Then just to recap, this is kind of everything that you need to have down. So this is kind of the nice little unit circle. Down at the bottom, we got the 0, -1. But these are the coordinate points. And again, this is going to give us, remember, x is going to be cosine, y is going to be sine. We said in class it goes alphabetically. X comes before y, cosine goes first, cosine goes with the x, sine goes with the y. So if we're over here on the unit circle at 30 degrees, if we make 12 slices, that's pi over 6. Those two are equal. in terms of degrees and radians. And then that coordinate is at square root 3 over 2 and 1/2. Now, the reason that that's the only one I have up there is if I really wanted to, which right now I do, I could just come down here and say, well, this is going to be the same x, but the opposite y. So I actually know this coordinate is square root of 3 over 2, negative 1/2. If I then travel over here, that's not very straight, but if I travel over there, now I'm going to be flipping my x. So negative square root 3 over 2, negative 1/2. If I want to travel, I hope I'm still red, but if I want to travel, I'm not red anymore. If I want to travel across this way, now my x coordinate gets flipped. Negative square root 3 over 2, 1/2. So we can see we make a nice little box. So there's a little rectangle, and everything that's on the rectangle, all the values are the same. The only thing that's different is the signs. So x is always square root 3 over 2. Sometimes it's positive, sometimes it's negative. Y is always 1/2. For the 45 degreer, for pi over 4, we also get the same thing. This time, though, the values are just square root 2 and square root 2 again. So if we were to draw this box, where's blue at? We can. So if I come down here, again, I'm going to switch the y to be negative. If I come over here, I'm going to switch the x to be negative. And if I come all the way down here, then both of them are negative. Again, I'm going to leave it up to you as an exercise to actually count them out. You can count around for the correct number of slices if you want, but all of those have the same x and the same y, just different signs. And the last one also works. The purple one also works here too. So the only other one is the 60 degree one. So again, this was the 30 degree one. The 60 degree one is the inverse of it. We can see that the x and the y switch. So 30 degrees and 60 degrees are inverses of each other. But if we draw the line out here, we'll see over there at 2 pi over 3, the x's are going to just switch. So that's going to be negative 1/2. So, y will still be square root 3 over 2. If we come all the way down, x stays as 1/2. Y switches to negative square root 3 over 2. And if I come over, both of them will switch, and I can complete the box just to make it look nice. So then down there would be negative 1/2, negative square root 3 over 2. So this is just another way that you can kind of think of it. And this is why we focused only really on the first quadrant in terms of memorizing them in class. That's why we didn't really focus on memorizing any of the other ones, because you can just derive them all. The axes are also labeled. So again, this is always going to be 0. This would also always be 2 pi if we were curious, but we always want to remember to start counting down here at 0. And again, that's at the point 1, 0, because it is a unit circle. And that's everything. So that's kind of the whole thing. A little bit of extra instruction. And then kind of disappointing with the TI because there's not much to do with it. But that's the entire video. So again, this is the last test. We'll do well, and then all that's left is the final exam.